There we
Great.
go. Great. Welcome, everyone. My name is Aaron Smith. I'm the CEO of the Energy and Environmental Building Alliance, joined as always by my great friend Nancy Bakeman. And we're excited today to have Sean Conta with Targa Homes out in Seattle, Washington, joining us to talk about achieving high performance with a code-designed project. We will have Q&A and the chat function open today, so feel free to enter any of your questions there. And this will be recorded and on our EBA Academy at eba.org and on our Better Homes, Better Future podcast. Sean, great having you here today. How's
Yeah.
things out? How's things out in Seattle? Your
Thanks
Mariners
for
didn't
having
make
me.
it.
We're about to get an atmospheric river, so
Oh no.
it's wet as usual in Seattle. We'll touch on that today. Building in a very wet climate is part of our skill set for sure.
For sure. And your climate zone, what are you, 4A, 5A there?
4C, 4C
4C.
Marine. Yeah.
4C Marine, that's right.
Yeah.
Okay,
Yeah, it's
awesome.
actually a somewhat temperate climate. Like it doesn't get that cold. We used to say it doesn't get that hot, but that's changing.
Yeah,
And I'll talk about that too, actually.
you've had a couple heat domes the last couple years.
For sure. Yeah.
And then of course the big news is your Mariners, didn't quite make it.
Guys, I don't watch baseball, but I got
Okay.
swept up in it, and it was pretty bummer.
Yeah.
I guess I'm glad I'm not a huge Mariners fan because I would have been more devastated. But yeah, it was
Yeah,
exciting.
he would have been crushed.
Yes. All
Next year.
right.
There's always next year. All right,
Yeah.
Sean. We'll go off screen and then I'll highlight your portion and you can dive right in. For folks joining us, we'll ask questions throughout today for Sean. So thanks for everyone for joining.
Yeah, I'm good with questions during. This shouldn't take too long, and so feel free to stop me. But yeah,
Awesome.
this presentation, we kind of go through our current project, and I sort of thought of this idea kind of early on because we were handed a code design project, and we are high performance builders. A little bit about Targa Homes. We're builders only. It was not a design build, so I work with architects or I'm given plans. The company is two nerds, myself. I'm on the right there. Oh yeah, you can see my screen, I guess.
Mm-hmm.
And Matt, my site lead. We're both passive house certified builders. We do like one or two homes a year. We're not looking to become some, empire. We like keeping it small, and we do high
Mm-hmm.
performance, low carbon builds.
Nice. And
Um,
how long have you been FIAS certified?
I just got my certification last summer. Matt has
Okay,
been for a number of years.
great.
Um, yeah,
And
so
are you finding that sending some business your way through their lookup tool?
not yet.
Okay.
Um, it's funny. There's still even in Seattle. I just went to the FIASCon conference where this picture is from, the national conference, and people think that Seattle is a hotbed of passive house, which it kind of is, but like the actual number of certified projects is actually still pretty small.
Right.
We're talking about next summer doing some passive house certified townhomes, and I always hope that the certification sticks with it. But I think that that training and that approach applies to all builds, of course, and so it's nice to have that kind of certification formality behind it.
Nice.
So yeah, that's Targa. We're a small company, but we try to be active, and I try to increase our impact on the world, I suppose, by kind of sharing what we do, and certainly in webinars like this and articles, Find Home Building, things like that. Um, and so yeah, in regards to high performance, we take this approach on every project, no matter really whether the client wants it or not. My approach has been kind of like, this is just what we do, and I will teach you about it, and as we go, and most people are open to that, but it's not like an option for us.
Yeah.
So to get started, when we talk about high performance, everyone kind of knows it all starts with design, right? That's how it's supposed to go. Um, I was trying to look up quotes from Pretty Good House, but there aren't really quotes. It's just sort of like assumed. Like chapter one is like, when you start design, here's what happens, you know, and it's like, and Fias, you know, it's baked into the process, right? You go through Woofy, that the big energy model, way before you even, you know, have pretty much designed the home. And so, um, you know, a lot of the articles I read and knowledge I have is based on this idea. It's like, well, when you're in design, you do this and you coordinate with this, and we do integrated design. And yet, what if you get an email like this, the one I got? This is an actual email from my current project. Hey, Sean, can you give me a bid for our project? We're pretty much to have our permit, and we're breaking ground in 2 months. Let me know if you have any questions, you know? It's like, okay, you know, this happens, right? I'm a builder. I can't control when someone comes to us. This project, so this is the actual email from June. Ron then sent the full design set, right? This is, you know, everything's done. I'm just giving you some, you know, kind of random pages here, but as you can see, the design is finished. By the way, there's not a single letter or line regarding HVAC on these or water heating. It's kind of just like, well, I guess we'll figure that out, you know. The design is fully engineered, as you can see. A lot of structure here. You know, we have a decent seismic element to our code, so you know we have a lot of hold downs and beams and lots of structure, which you can see here. Even all the assemblies, right? Like it's all defined, right? So okay, I'm a high performance builder. What do I do now? Okay, and the reason, you know, I wanted to kind of create this presentation is like, I think a lot of people probably find themselves in this situation. There's certainly not everyone's design builders, a lot of builders out there. And I think probably a lot of builders say, oh, well, I guess we'll just build the house to code. But, you know, I want to kind of go through today, like, there are a number of things you can do. And it's harder. It's certainly easier to start in design and bake all this stuff in, but it's doable, right?
Yeah.
Here's the outline that we're going to talk about today. Building a really airtight home, well thought out.
You're targeting 0.6 there, right, Sean? For
yeah, we hit
house rating.
You know, and by the way, Fias is actually not 0.6 anymore. It's 0.04, 0.04 or 0.06 cm per square foot of shell. So they do the shell calculation, which I think is a much better metric. But yeah, yes, so you're not getting the
volume discount on that.
Exactly.
It's better for smallish houses too. So
yeah, it does skew. So I think, you know, by the way, everyone, we should do CFM per square foot of shell. It's an even playing field. It's great. So yeah, we try to hit that, and we do hit below that, sometimes half of that on all our builds. And you know, Matt and I are just nerds also. Like, do you have to do, is that like required to have a good home? I don't think so, but it's kind of fun, and it's you know, leads into durability and efficiency and all these other things. So
yeah, well, I always like the question, Sean, like, how many holes would you like in your house? And people are paying you $1 million, and they're like, I don't want any holes in my house.
Yeah.
Oh, okay, yeah. Great.
I know. It's pretty cool, and like I love the little tricks you can play. Like you open the front door and the dampers flaps from the range hood. But it has a lot of benefits. We're going to talk about that, you know. But yeah, so air tightness, you can kind of do that on any build. You know, it can get harder. Well thought out HVAC, we'll talk about that. Some envelope kind of modifications or substitutions. Building in durability is a big part of it, and lastly, lower carbon, which isn't, you know, operational energy, but is upfront kind of carbon. So that's the outline, everyone. So I'm going to go through how we achieved this on this, and I'm kind of using our current build as an example. So air tightness, planning out the air barrier location, transitions, and penetrations, right? Matt and I spent a bunch of time going, okay, well, what is the air barrier? Maybe you've heard of like the red line test, where you just draw a red line around where the air barrier without lifting up your pen, right? And so it's a little bit, you know, figurative, but the concept applies. So this house is 3 stories above a unconditioned kind of basement garage storage, right? So our general approach is to use zip sheathing with tape seams. So that sheathing is with integrated WRB is our air control layer. That's kind of our general. Usually we start there. Zip's great. A lot of other things work as well. The advantage for us on zip is that our framers can frame like they normally do, and we come back and we do the taping and the detailed work. So if we say that zip, the walls we understand pretty quickly. One transition, the first transition I want to call out is the floor. Okay, so also we said we don't want the garage to be part of the conditioned space. Doesn't really make sense. So our air barrier, we said, is going to be the subfloor. And so, well, you can tape the subfloor seams, but how do you deal with that? How do you transition that air barrier from the subfloor to the surface of the, the face of the zip? And the way we do that and the way we came up with is to use this gasket. This is an actual shot from the site. This is the first floor, subfloor. Later on, we'll go and we'll tape the seams, but before they build the walls, I said, hey guys, stop. I bought this gasket from, I think the Energy Conservatory, one of those online sites. It's like a nice little neoprene, I think, rubber gasket. I stapled it up. And guess what? When they tip this is like an example. I was just holding this sheet of plywood up, but it squishes the gasket. Now we've got a connection, right? By the way, like the bottom wall plate is right here. I can't really get to this easily later. And so that's why you kind of have to, know the point in time when you want to do this. But that ended up working well, you need to have a nice crisp line on your subfloor. So sometimes I've had framers route that, but these guys did a good job. Okay, easy, right? Well, what I didn't show you is the other section where, actually the stairwell like pokes down into the garage and kind of like ruins that like neat neat line.
The best laid plans, right?
I know. And so, I mean, why do we need stairs? Well, okay, we need stairs. So, okay, well, this got more complicated, and this is the kind of thing where in design, I think we could have attacked this a little differently, because not only are the stairs poking down, but we have this odd detail where the concrete wall at the stairs is built, and then the framed wall is framed inside of that concrete. So if I go back for a second, you can kind of see over here, if you can see my cursor, there's a concrete wall and a framed wall inside of it. I don't really know why they did this. I'd like to think, again, if we were sitting there in design, we could have said, hey guys, let's align these. It would make life easier, because with our approach of like, the sheathing is the air control layer, well, yes, in a perfect world, we could have just taped all this, but that's one of those things where we weren't there that day or that hour that they framed these plywood walls. We just didn't have access to that. Also, by the way, there's outside corners there. We could never really tape behind the concrete wall. I mean, there's a 1-inch gap between the concrete and the plywood. So, okay, we ended up doing like what I would call 1,000 cuts. Okay, we got the blower door running. And by the way, we do this on every project right before installation, assuming we have an unvented roof, which we do. I think it's a great time in the project to understand where you are on air tightness, because now I can actually do something about it much more easily. I can see gaps. I can use my smoke. I can feel air coming in. So back to that like stairwell area, we ran the blower doors. The blower doors depressurizing the home, and I got a little video here. Hopefully everyone can see this, but this is me in that little area with this. This is the new air tracer from Retrotech. It's awesome, and you guys can kind of see there's smoke shooting out of this little crack here. Let me play that again.
Is that the crack in the concrete to the left that it's shooting out of?
It's between the wood and the concrete, and you can see there's a little like flap.
It's where you got your spray foam there.
So I have a can of it's foam, and I'm foaming that up. And by the way, there was some air coming between this stud and the plate.
Yeah.
Is this the best way to do an air barrier? Absolutely not. I'm the first person to say this is what I'm calling this kind of like 1,000 cuts. I don't want to have to be doing this, but here we are with a project that's already designed, and you know what? This worked pretty well, right? We got below passive house on our prelim. Here's the smoke again. You can see it's a lot more kind of stable, right? There's still a little blowing here and there, but we've accomplished a lot just with that. And so I went around and did this in 20 different places in that stairwell because a lot of leakage was coming from that, as we expected, right? So yeah, I mean, that's kind of the last. I'll touch on air tightness one more time in the roof, but I think the takeaway is you can build an airtight home without having planned that from the start. It's harder, but it's doable, and it's a lot of attention to detail and blower door testing. Any questions on that before I go on to
Sean, did you ever consider something like AeroSeal where?
Yeah, I love Aero Barrier. In Seattle, we got an early demo before they even started. At the time we were like, this is amazing. And I think it is. And my goal, Aaron, is to never need it.
Right. Because, so try to be good enough that you don't need it.
Yeah. I like to feel like our primary, WRB, our primary air control layer is enough. And certainly it's a great tool in a lot of cases. So yeah, could we be using this project? I mean, I felt like from the first floor up, we were going to be in great shape. So it's kind of like it would have been a lot to do the whole house, and I really only needed that stairwell. So I kind of we got there. And by the way, when we turned the blower door on, from that picture I just showed you, we were close. Actually, funny story. We turned it on and we were not close, and then we noticed a window had blown open upstairs. So that's always a good day when oh shit, the window's open. You close it and the fan ramps down. So
yeah. Usually, I mean, when I had my house done, usually the guys from testing can tell you've got a window open somewhere. Like they just know right away, right?
Yeah, and by the way, I used to do blower. I did hundreds of blower doors, so you just know from the fan speed,
That's right.
You like to hear it just ramp down. So anyway, so yeah, moving on to HVAC. Like I mentioned, there was no HVAC on the plans at all, and I'm a big fan of thoughtful HVAC design, matching load with equipment. And so my first, in our market, a lot of people just kind of put a mini split head in every room. And there's reasons why I think that's a bad idea. My first move here was to hire Energy Vanguard to provide services for us, HVAC design services. And the first thing they do is a really detailed load calculation, or manual J, if you've heard of that, right? They're taking all the info from the building, the windows, walls, roof, assemblies, air tightness assumption, solar shading, solar gain, and basically finding out how much heating or cooling this building needs. And you don't know that until you know that. And so to come in and put in a 3-ton furnace or even mini splits, might be a bad idea. So I'm a big proponent of this. It was great working with them. We ended up with they do equipment selection and duct design. In this project, we ended up with ductless first floor and third floor, but the second floor, where you can kind of see, hopefully here, there's a lot of bedrooms. There's 1, 2, 3, 4, 5, 6, 7 rooms on this floor. I'm not putting 7 mini split heads in here, right?
No, right.
Like this bedroom is whatever, 200 square feet. It probably needs 1,300 BTU hours of heat, and the smallest mini split head is 6,000. So this is what I'm talking about, matching load with equipment. So we ended up with an air handler in the floor above, feeding ducted heating and cooling to this floor. We spent a lot of time thinking about structure. Honestly, I mean, these guys the load calc and equipment selection was the easy part. The hard part was, how am I going to get from here to there with 7 beams in my way? And again, if we had been in design, I could have said to the engineer, hey, can I have a chase here?
Sure.
To run some ducting,
I mean, did you at least have an option of like open web floor trusses to get through or not? You had to just make it
We
work.
did not because it was all designed with TJIs.
Oh
Open web
boy.
trusses, the minimum open web truss is much taller than a TJ,
Yeah.
and we were at the height limit, So
Yeah.
I love open web trusses, Aaron, right? Like, great, of
I
course,
know.
right?
By the way,
Uh,
best there's Aaron and Sean's pro tip for the day. Open web trusses for all.
yeah, it's awesome.
So much better.
And I would push for that. I mean, but I will say, like, the downside in our market is they are taller, and people
Hmm.
are always right up against the height limit, so that kind of have to take that into account. But yeah, it makes it so much easier. I drilled so many holes in TJ webs, and we did go back to the engineers on a number of occasions and say, hey, can we do a 3-inch hole here instead of the spec 2-inch? And they were like, sure, space them. They gave us specs, which was good.
Nice.
Um, the other thing we did was used a new duct distribution system called RHEIA. It's a company called
Yeah.
RHEIA, RHEIA. It's basically a ducting system made with this 3-inch flex. This is 3-inch uninsulated flex. And they have a cool system of fittings where you kind of just thread them on. It's pretty easy. But the main reason I used it is because I had to fit ducts, still, even though it's a brand new home, in tight spaces and 2x4
Mhm.
walls. And so it ended up being a pretty big spaghetti. This is the manifold. You can see down here the Mitsubishi air handler, the SVZ firing to the side. This is a simple sheet metal manifold, and all the takeoffs come off of that. So all these 3-inch ducts go to a bedroom. These will run like 20, 30, 40 CFM. So some bedrooms had 2 or 3 or 4 registers, which are like little 4-inch round discs. So it's pretty slick. It was a good tool in this case, although it was still a challenge to just run everything. Yeah, so matching the system to the load is important, and we achieved it here with kind of a mix of ducted and ductless. Let's talk about assemblies. I think I lost a slide here. But next up would be like things we can do to the assembly, the envelope after the home is designed. A big one is windows, right? The architects put some windows in the plans. I don't know. I kind of always ignore that. Whenever I can, if budget allows and the client allows, we do like a European-made tilt-turn window. They're very well made. They're very durable. They obviously very high performance, triple pane, and we always use triple pane windows, frankly, for performance, for sound, but just the fact, I don't know if people are familiar with kind of radiant temperatures and how that affects comfort. That interior pane of glass on a triple pane window is warmer than any double pane or single pane, of course. And so that radiant temperature, the mean radiant temperature in the room is higher, and people feel more comfortable in that case. My homeowner, Ron, my client, he started joking, damn you, Sean, you've made me care about windows. He had done some development, some spec development work in the past. And he's like, I used to spend 10 minutes thinking about windows, and now I'm 20 hours in. He's like, but these are so cool. He really cared about this. Once he understood kind of the performance, the features, how cool these windows are, he really got into it. And so it was a much more expensive window package than he was planning. But one of the things I say is invest in the envelope. You don't want to change your windows
Well,
in 20 years.
and Sean, I think, being dealt a set of plans, my intuition is that one of the biggest things that you had to do was to get to triple pane windows to improve that envelope, right? Because you couldn't change the depth of the wall. You probably couldn't put continuous insulation on the outside. I mean, you really needed to get some good windows
Yeah.
in there, right?
I mean, Aaron, the window is the weakest part of the wall.
Yeah.
And we could have done exterior. We didn't try to get there in the budget, but But yeah, this, we have R23 cavity insulation here. This windows are, a code windows R3, and this one's R6, which is still worse, but a lot better. So yeah, I'm always a proponent of the best thermal performance from the windows that you can afford, for sure.
Great.
Okay, sorry. I just wanted to show people, if people haven't seen a tilt turn window, the operation, this is the turn. This is a little video I put on Instagram, but that's how it, they open inward, and this is the tilt operation, which is like a ventilation thing. And so it doesn't go past that angle. There's still security, but it's a lot of ventilation. So yeah, so that's the tilt turn window. They're pretty cool. Of course, in Europe, they're just a window.
And did you use H windows from Germany?
No, these are
similar.
Yeah, there's so many window manufacturers. These are Giallen windows made in Poland. I use Pivot windows out here. My guy Andy is a great importer of many different windows. These were UPVC windows.
Okay.
Obviously, you can get thermally broken aluminum for a higher price point. They're beautiful, But they were more on the more affordable side of things. But
nice.
In terms of roof, one of the things we always do is what people call monopoly roof. The more generic term is like an overframed roof. This was not in the plans. We just did this. We had engineering details from previous projects for these tails, but let me kind of explain what it is. So as you can see here, basically you frame up a home without any overhangs. So you make a really simple box that you can make airtight easily because they just tape all the corners, all the seams. This is sort of mid taping. And by the way, the DADU back here, we had to do a different kind of roof, which I couldn't get into now, but for height reasons. But we're looking at step 1 here on the single family, tape all the seams. Step 2, bolt on your tails, your eaves, your overhangs. We bolted these through with a 6-inch Simpson SDWS burly lag. Each tail I think has 3. You can jump on this thing; it's very sturdy. That kind of builds out the roof overhang. And by the way, architects love this because I could do, this is a 2x4 on edge. It's a nice thin profile. Architects love thin profiles. So it looks like a really old roof, but it's high performance. The next step is to fill that with, in this case, rigid foam, but any sort of insulation would work. This is GPS foam, 3.5 inches, so it planes right out with those 2x4s. There's a lot of cutting, between the tails here, and we did the special angle boards, which are hard but look great. But then the field is just full sheets or, easy cuts. And then on top of that is another layer of plywood, and then the underlayment, and then roofing. So this is kind of the last step before roofing. Why is this roof awesome? First of all, we essentially have built 2 roofs, right? This is a watertight layer with the zip. It's also nice during construction. We've sort of waterproofed the building in midstream here. We then add a roof on top of that. Like if this roof ever leaks, it's going to leak onto the zip, which will drain to the rain screen. We avoided spray foam with this. I don't like spray foam for a number of reasons. It's toxic, it's expensive, but also, especially new construction, it can fail, right? The framing, lumber shrinks or moves as the building kind of settles in. Once you have a crack or a delamination, warm interior air can reach cold sheathing, right? This sheathing could be very cold. And so when you put foam above the sheathing like this, it keeps the sheathing warm. You have to make sure you have your ratios right. But in our climate, 3.5 inches of GPS is plenty to have that sheathing never below dew point. So durability is great, right? It's an unvented roof, great for fire zones, and also just for kind of, if you, in this case, everything's vaulted, but if you had an attic, your attic would be a conditioned space, great for mechanicals. Okay. what did all that result in? I added this morning. You know, it's worth saying like this house has a heating load of just over 1 ton, um, which I think is pretty low. It's a 2,600 square foot home. It's not huge, but you know, I could definitely see an old school kind of contractor coming in with like a 2 ton furnace. It doesn't need that much. The cooling load is much higher, you can see. Now, part of that is because the design temperature, when I was working with Alex at Energy Vanguard, and he's like, what's the, we're getting back to Aaron and I were talking about the weather in Seattle these days. He's like, I was like, what is the design temperature in Seattle? He's like, it's, 88 maybe. And I said, well, that's nice, but I've lived here for 18 years. And the last 5 years, we've hit 100
Hmm.
every year, maybe for
Yeah.
multiple days. So like reality is not matching that anymore. So I had him move up the design temp, I think to 95 or 98. And so that definitely increased the cooling load. We also, although we used awesome European windows and blew up my owner's budget, we did not have any budget to do a lower solar heat gain coating on a lot of those windows. I think one or two I did.
Mm.
That would have helped cooling load certainly, but frankly,
Yeah.
I strung him along through this window process, and at the end, I felt like I couldn't be like, oh, by the way, now we have to tune each one and add, 40, $50 a window. Um, but so it's really a cooling dominated house, which is crazy in Seattle. But that's where we're at, and so really
Hmm.
the peak loads of the HVAC system are for cooling. Okay, durability. Arguably I should have put this first, right? We live in a wet climate. Water is the #1 killer of buildings. And so this is a big focus of our approach. The good news is, and this is what you learn in passive house builder class, like when you prioritize durability, a lot of the performance things kind of come with that, right? I mean, durability, air tightness is a big durability thing. Let's not allow moisture, over that membrane. Um, yeah, managing moisture in and out of the building is a big part of durability, and also, by the way, leads to pretty good efficiency. So there's a lot of aspects to this in this project. I'm gonna use an example of this third floor deck over living space. This is kind of one aspect of the project where Matt and I really thought about how are we going to do the best possible assembly here. Whenever you have a deck over living space, we're as builders, I think most people are kind of like, oh boy, this is a bad choice. Like, if you can design these out, I think it's a great idea. It's just a risk, right? It's not really a deck, it's a roof. And yet we're putting traffic on there. And so it's really risky. We like to avoid spray foam here too, and by using foam above the sheathing. And to the architect's credit, that's how they drew this. We only changed, they had the slope in the foam. We changed that to have the slope in the joists. We modified it a little. And here's how we built this assembly. So we said, okay, this is that actual deck, right? So the structural sheathing will be our air control layer. We'll tape all those seams, which you see here. So our air control layer, by the way, is coming down the wall and over the deck surface, and then again to the wall. We then said, let's put we're going to put foam on top of this, right? To get back to the kind of double roof scenario, we said, in past projects, we've gotten to this step and we said, oh, let's just put a membrane over it just for like at least keep it dry during construction. And this time we kind of said, what if we actually just more purposely make a backup drainage plane under the foam? We could put this blue skin down, self-adhered blue skin, on the structural sheathing. So that's what we're doing here. Okay, so now we have a watertight layer, but we still have to put the foam on. So over the blue skin, before we put the foam on, we have this little matrix, this kind of, it's called mortar vent. It's actually made for going behind brick, but it's a plastic matrix just to give a gap, right? If we had the foam tight to that Henry, there wouldn't really be a capillary break to actually promote drainage. So we have like a really, 1/4 inch gap here below the foam. Doesn't affect thermal performance, but provides a drainage plane if this roof ever leaks. So we have that down. Here you see the foam. It's maybe kind of hard to see, but these are white sheets of EPS. So that's our insulation layer, and then above that, in this case, PVC membrane,
Hmm.
which is, sort of seam welded. So, okay, I mean, this is our deck. I mean, I'm now building a, walking deck surface above this, but this is our primary water shedding layer. Will this last forever? No. Like, that's sometimes the thing we say to ourselves, like, this will not last forever. So what happens when this leaks? Well, it'll leak through to the foam and then under to this and then drain out into the rain screen,
Hmm.
So it's kind of a backup system, right? So this is, I think, a durable um, assembly. I then got even more paranoid because at each post, kind of support post for the parapet wall, that is sort of a risky spot, right? There's kind of a penetration. They they welded the PVC up and around it all, but I said, well, let's just put some Prosecco on those seams, just because that seemed like the highest risk kind of potential.
Hmm.
Um, so yeah, any questions on that?
So then you just put wood deck on top of that,
Yeah,
like
like
a
so
floating.
this whole thing is sloped, and you can see it's not like a scupper, it's like a sheet flow.
Yeah,
Because again, like a scupper is just asking for leaks. So there's a
right.
gutter on the outside behind this. But yeah, then I ripped PT kind of joists opposite slopes so that we have a
Yeah.
level and put decking on top of that. Yeah,
So it's
exactly.
essentially a floating deck on top of there.
Yeah, exactly.
Yeah.
It
Nice.
drains under the deck. Yeah.
Yeah.
Um, Rain screen. We always do rain screen siding. I'm
Hmm.
sure people are pretty familiar with that. Wet climate, it's the best way to do siding, right? It's allowing any water that gets through the siding to drain down, but maybe more importantly, allowing air to continually dry out the siding material. So this is standard for us. Here you can see our siders doing that assembly, and it makes the siding last longer, and it's a great way to do it. Okay, we're getting close. Last section, carbon. Um, this is like a little different than like building performance. But if people are kind of reading up on this these days, the construction world kind of breaks down into operational carbon, which is the energy the home uses during its life, and embodied carbon is sort of the energy that it takes to make the materials that create the house. And so we're doing, a lot of great things on operational carbon, like I'm showing in an efficient envelope and smaller mechanicals and efficient mechanicals. Um, and we're starting to turn our attention a lot more to the embodied carbon of the materials. And it's not a huge battle, We use a tool called Beam. If you guys have heard of this, it's a free estimator. It's not a calculator, they say. It's like a pretty lightweight, easy to learn tool on your computer for comparing choices in materials. Um, Anything from concrete to siding to walls, insulation. Um, it's a pretty cool tool. I suggest people check it out. It's built in a Google spreadsheet. This is what it looks like. You basically enter the dimensions of your building, um, linear feet of concrete, wall areas. And then as you go through the different tabs, you make choices. If you can see here, we're looking at exterior walls, right? So we have wood framed walls. Well, if I use, typical 2x6 SPF lumber, I click this checkbox and it kind of populates in the net kilograms of CO2 equivalent. But this allows you to see really easily, the difference between choices. Maybe not the best screen to have picked, but you can see 2x8s are a little more just because it's more wood. And there's choices in here that are negative, right? Like biogenic kind of carbon storing materials. So we've used this tool. It kind of spits out this graph, a cool graph of like where are you at, um, carbon emissions by section. We're looking at, positive emissions of footings and slabs. Concrete's a huge one. The more lower carbon concrete we can use, the better. Exterior walls. This was probably for a project where we used some wood fiber cork insulation. So that's carbon storing. So that's a little negative. But this, you know, this tool, I think, is a good and not too intimidating way to understand the embodied carbon in the materials you're choosing. And spoiler alert, things that are biogenic or like wood-based are better, So less
Mhm.
carbon, steel, glass, more wood fiber, stuff like that. So um, the stuff that moves the needle for us is concrete. We have tried to get some lower carbon mixes, and there are some low hanging fruit in our market for that. Just kind of asking the ready mix guys, hey, do you have a lower carbon, SCM supplemental cementitious material? And a lot of them do. Um, Insulation, we when we're doing exterior insulation, which has been, maybe half our projects and probably an increasing number, and it's a great assembly. We like using a really low carbon material. This is a wood fiber board. Wrapping this home. This is a Styco product, but yeah, Timber HP is
Mhm.
coming out with their product domestically, which I'm really excited about. It's a great product, really easy to work with. Um, yeah, this is what our go-to. We've also done cork. Cork is super cool. It's like, it's the bark of the tree. It grows back. This is just 100% cork. They just heat it up and it binds to itself. It's a really cool product. Slightly more difficult to work with than the wood fiber board, but really cool. And actually has a really good fire rating.
Mhm.
Um, we use cellulose in cavities when we can. It's a carbon storing material. Um, and siding. I've been using LP Smart Side. Nothing too fancy, but it's a wood-based siding. Hardy is the dominant product in our market, which is a fiber cement, right? Cement is the thing that takes so much energy to make. And so this wood-based siding has a lot lower embodied carbon. And people, LP used to have 30 years ago, they had some warranty issues with this. Um, they've solved all that. And also, by the way, it's on a rain screen. So that mitigates a lot of risk for any siding material, just because it's continuously drying. So anyway, those are just a few of the choices we make. And I'll have to admit, like once you kind of use the beam tool and say, oh, this is the kind of thing that's better, and this is the kind of thing that's worse, you don't have to keep. I mean, you should keep using the tool and on every project, but like that sort of thinking just kind of gets into your process, right? Like we always use LP now, and if someone wanted me to use Hardy, I'd say, well, what about, or not LP? I'd say, well, what about just wood or some other options that have more bio-based materials. So you pretty quickly, I think, get that kind of thinking.
Mhm.
Um, okay, that's pretty much what I had. Um, so to recap, uh, where is it? This is kind of the categories, I guess, of how I thought about this build and how we can do better with a design that we didn't really have any control over. What do you think?
Yeah, and
Any
let's
questions?
yeah, just a reminder, everybody, if you have a question, put it in the Q&A or in the chat section, and we can make sure and answer that for you. But I like the presentation, Sean, because this is how it works out sometimes, right? You're not design build. You get dealt uh, a hand and you've got to play that hand, but where can you improve it? Where can you upgrade it? I think you've done a nice job of kind of walking us through that. I'm interested though on your HVAC, as I think you said you're roughly 2.5 tons on the cooling side. So you had a mini split upstairs, you had a mini split downstairs. I assume each of those were like 6 or 12 or 18 or something like that.
Yeah.
So
Um,
you don't have a lot of balance on that second floor where you use the RIA system. I mean, were you able to find a mini split or a heat pump that was small enough to deal with that? Because you have a really low load home here, right?
right, right. part of that, yes. So part of that advice and guidance from Energy Vanguard was about turn down, right? We talked about that a lot. Because you're right, Aaron, like, yes, the system has to work on the coldest and hottest day of the year, but most of the time it's working somewhere in between or much lower. And so when we chose equipment, we really looked at the turn down ratio of like, I remember like substituting, because in some cases the Mitsubishi, hyperheats are better for turn down, and in some cases they're worse. And so we just looked at the specs of the equipment and said, oh, well, this one goes down to 4. And so, but up to, 15. So let's choose that because you're right. Like these are mostly operating somewhere in the middle. Yeah, I think we had a 1-ton. I think we had a 12K ducted unit, and on the first floor we used the ceiling recessed Mitsubishis. I think the smallest one is 9.
Yeah.
And then on the top floor, I think another 9K regular wall-mounted head. But again, yeah, they all turned down quite a bit from there.
Nice.
Yeah, and in the Dadu we're using 2 1-to-1 systems, so one compressor to one indoor head. I like doing that also for turn down, also for efficiency. We have found that 2 separate compressors, 2 1-to-1 systems is not that much more expensive than a multi-zone, a 2-to-1, but will operate more efficiency with more efficiency, more flexibility, and more turn down.
Oh, that's great. Anything else, any plan for solar added by the homeowner after, or battery storage, or heat pump water heater, heat pump dryer? Did you do any other cool technologies as you thought about this house?
Yeah, great question. We did so solar we pre-wired for or put the conduit in to make it easy. I don't know. He does plan to do that someday. The Dadu was pretty shady, so we just did that in the single family. In both cases, we're using heat pump clothes dryers. Yes.
I love those.
Yeah, they're great. They're good. Even on my last project, we used a combination unit from LG. I think no, GE has a nice combination. So it's like one unit washes and dries with a heat pump. Pretty cool.
Yeah.
And then water heating. Yes, I mean these are all electric sites. So we were using a heat pump water heater in the single family. Where is that? I guess you can't really see it, but we're putting the heat pump water heater in the single family in the garage because that's a no-brainer, right? It puts off cold air. In the Dadu, this has come up on a couple projects now. So the Dadu, and by the way, that term is detached accessory dwelling unit. That's our local term. I know everyone has a different, backyard cottage or ADU. That structure, which by the way, back here does not have a garage, and is 1,000 square feet, fairly tight floor plan. Which makes it harder to locate a heat pump water heater, right? We know they're a little noisy, they put off cold air, and so for the second time, what we've done, because this has a stairwell that turns, right? So the architects had intended to have a water heater under the stairs, but those heat pump units are tall. So you would have opened that closet and lost all the storage space that goes around the stairs. So I convinced the owner to buy a Sandon or Sanco split system water heater. If you've heard of these, right? It's
a CO2 based, right?
Correct. CO2 refrigerant. Yes. It's got an outdoor compressor, which makes hot water, very hot water actually, and there's plumbing pipes that go into a totally silent static storage tank inside. That storage tank is 43 gallons and really small. And so we can tuck that around the corner of this winding stairs, kind of put it in the back, and you've gained like 30 square feet of storage space, of floor space, which in Seattle is pretty valuable,
Yeah.
And so,
that's right.
fortunately, the unit is, 3 times the cost of a heat pump water heater, but when you kind of, I think factor in that like square footage, it can start to pencil out. And they're beautiful, units, right? They're silent, completely silent. They're super efficient. And so we use those when we can. So that's what we used on the Dadu. But yeah, all electric, all heat pumps. Yeah.
Great. Well, Sean, thanks so much. We apparently answered everyone's questions today, so yay
There's nothing else
us.
out there. I mean, I do have a few more slides if you want to. This is
Yeah.
our real quick flashing sequence. I just threw these in at the end. Like, I talked about the air control layer,
Mhm.
um, things like duct penetrations or vent caps. We put a lot of attention onto these. I drill a hole. I use like an EPDM
Mhm.
gasket that's sealed to the sheathing, and then you can basically poke that duct through and move it in and out.
Mhm.
That comes into play because like if you have exterior insulation, well, I want to put this on first, but my siders need to side around that. I need to fit insulation around that. So the ability to move it out and nail it back up is really nice. And so that's what these allow.
Mhm.
It's an airtight, watertight juncture, but it has flexibility. And so I leave it
Nice.
like this, and my siders come and nail a couple furring strips behind that
Mhm.
and place that block on the rain screen, and off they go.
Nice.
So anyway, just a little tidbit. These are the kind of things that we've come up with over the years. But these gaskets are pretty easy to come by. 475 has them.
Mhm.
And I think they're really nice for flexibility and a lot of penetrations in a house. And
Mhm.
those can add up in terms of air leakage and be hard to deal with. So yeah,
That's great.
that's the deal. This is a
And
shot from 2 weeks ago.
what the heck is going on in your driveway right there? Why are you pouring a giant footing in your driveway?
You talk about this thing?
Yeah, what the hell is that?
Yeah, that's a bioretention planter. So it is a concrete box that the downspouts from the dadu go into. It's basically a stormwater retention device that's common in Seattle.
Okay.
Because we have a combined, in a lot of areas of the city, combined stormwater and sewer system. And when big rain events, we're
Mhm.
dumping so much water into the sewer system that like it will overflow into the sound and it's bad. And so slowly
Okay.
the city's been trying to slow that flow into the sewer, and
Mhm.
devices like this. We had a bunch of them actually. Um, we'll fill up and slowly soak into the ground, but they'll overflow if needed into the sewer, but it really slows that. So yeah, all stormwater. Um,
Wow.
yeah, and as you can see, this is a really traditional style home.
Mhm.
Kind of nice. I actually live in this neighborhood, so it's kind of nice to be building a house in this neighborhood. And also, there's a tendency in Seattle to build like more like this, the Dadu, like boxy,
Mhm.
modern,
Yeah.
of varying degrees of aesthetic, skill homes. And so having a really traditional look, but a super high performance home, I love. All the like old ladies that walk down the street during the day yell up at us, "We love the house. I'm glad it's not a big box,"
Yeah.
which makes us feel good. But it is really cool, I think, to have a very old looking, especially with like you can see the roof line, right? Like these are the,
Yeah.
exposed soffits, right?
Portals. Yeah.
With the tails showing. I mean, this is the house next to us is probably 100 years old. It
Yeah, it
also has
fits.
like
It
tails
fits, right?
sticking out. So
Yeah.
it's a very traditional look, but it's a
Yeah.
super high performance roof.
Yeah.
Super durable,
Oh,
It's cool, I think.
I like it.
Yeah.
Well,
Well,
great. Sean, thank you so much for joining us and sharing some of your lessons learned on this. And
it's been
we
great.
will, yeah, and we will post this at eba.org and the learning management system, and then at Better Homes, Better Future podcast. So thanks to everyone for joining us here today. And Sean, again, thanks so much to you.
Great. Thanks, Aaron. Thanks, everyone. Appreciate it.